This is a project, it's part of a bigger project that may or may not ever get done, involving those little Radio Shack amps. Anyways, I was going to put a beefier power supply in them. This is kind of a harebrained idea. So just in general though, for making a power supply for an amplifier, or any time you want to make a split power supply, and in this case I'm going to tuck the whole transformer and then the whole output for the numbers I'm going to use here. So X is my RMS voltage of the transformer I want to buy. And I determined I wanted 20 volts across the whole power supply, which is actually 210 volts. And this transformer is actually specified as 2 voltages sometimes too, but we'll get into that. So RMS voltages is my X for my wanted voltage for my transformer. X times the square root of 2 represents the single peak voltage of it, minus 1.2 volts DC volts for the bridge rectifier, and that's a real minimal number. You know, under draw they'll drop a lot more voltage than 0.6, but it's going to always go through 2 diodes at a time in a bridge rectifier, so that carves out 1.2 volts, minimal. So, and I want it to equal 20 volts when I'm done, DC volts. So move things around, you know, add this to both sides, then divide both sides by the square root of 2, and you get X equals 21 over square root of 2, or 14.9 VAC transformer. Okay, I bought a 14 volt transformer. Couldn't get exactly what I wanted. So what am I going to get? I end up calculating 7 volts AC. So 14 times the square root of 2 for the single peak minus the 1.2 gives me 18.6, or plus minus 9.3 volt lines. And this is just a diagram of the transformer. It's actually 4 coils. I gotta pair them together to make it look like a regular single tap transformer. In fact, these are just going to join together and not go anywhere else. They'll just be tied together. And these two will tie together to form a center tap. And then here's the circuit for the, the whole circuit. And these extra set of capacitors are probably going to be like 0.1 ceramics or polyester, something or another in that vein. Ceramics are a little bit better at taking the high frequencies out, the ultra, RF frequencies out of the power supply, but they tend to blow up in power supplies like this as well. Even when they're grossly overrated, sometimes they'll just pop. Probably not a little power supply like this, so I shouldn't have any trouble. It's in the bigger supplies, you got to worry about it. And the transformer I drew just for the identifying the transformer, and how I'm going to put these 4 coils together to emulate a regular transformer. So these two are going to end up parallel together actually for 120 volt usage, I believe. 240 I'd put across both coils. But for 120 I believe I got to parallel these up. So the reds will go together and the blacks go together. Here I'll be tying one green and one blue together to form the center tap. Gonna have to use diode mode. So let's select it. I said volts, that's where I wanted to be. So, I go from here. Got a junction forward biased. With a junction forward biased. So I already know this is my negative if my probes are right. And then just to check that the thing's okay, I shouldn't get anything here and here, or here. So, and probably this is the positive too, then. And the middle two are going to be AC. Junction. No. I got a blown diode in here. Uh-oh. Well, maybe I don't use this one. This shows two diodes this way, so why can't I get anything out of this? Weird. Well, this is a defective part, which is not surprising. I got lots of junk like this. I've bought so many bad bulk bridge rectifiers. At least 2 batches, if not 3. Here's an old Radio Shack part. I got a box of old Radio Shack stuff. Dug through because I can't find any other rectifiers that actually work. And now I dropped it. So the longest lead should be positive in most cases. Should be all cases. Let's see if that's true. It's onto diode mode. No, wrong button. And I believe this ohmmeter is polarized correctly, unlike the Radio Shack one. That was my longest wire, right? So I should get 1.2 more or less volts. Yeah. Yeah, about 1.2 volts. And these should be 0.5 or 0.6s rather. Okay, so all 4 diodes work. And I'm putting into the positive instead of taking out of it, so I was backwards. So I'll solder it up and see what we get. I've got the Variac just off the screen here. I'm going to set it for 120 volts even to make it fair. Give these poor capacitors a slight break too. Okay, there we go. 120 on the nut. So what will we get for DC? That's the whole point of this. To see what we'll get on DC. Is my calculations correct? The biggest variable is going to be the transformers themselves. Sometimes you buy a little transformer, they'll say 100 milliamps at 12 volts. And 12 volts, but it won't give you both at the same time. Most transformers are expected to give you the number at the same time. So I've got 9.9 on one side and 9.9 on the other. So it's a 19.84 volt supply, which is pretty close to what I calculated, I believe. It's a little higher, actually, I think. Let's see, what did I come up with? Oh, I went plus or minus 10. That's kind of what I was going for. And I calculated 9.3. So yeah, I'm a little bit rich. Not a problem. It's actually kind of good. I kind of wanted 10. So I got what I wanted. Even though my calculation's a little bit off. Not too much, though. 0.7. And to give you a closer zoom of my handiwork here, just 2 capacitors, bridge on the side, all twisted together. It's not even soldered yet. And now, just to show that the diodes are going to drop more voltage when they got a load on them, I've got a 470 ohm resistor across the whole power supply now, and it sunk down to 18.06 rather. And that's down from 19.47. I haven't changed the variac or calibrated my 120 volts, but it's the same as it was. So that shows the draw. So the transformer's going to sink a little bit, but mostly it's the diodes are going to start dropping more voltage.